Hello, my name is Rich Howard, owner of Architectural Builder Supply. In this video is to bring you a closer look at the Bommer number LB4321-400-633. This is a spring hinge, is what this is. And let's dissect the part number. First of all, LB stands for lube bearing from Bommer. That is a maintenance-free, sort of concealed bearing assembly that's here and here in these two knuckles. The 4321 conspires to mean it conspires to mean its physical, many of its physical properties. That part number certainly means that this hinge is going to feature a 1/4 inch radius on all four corners. It also means that this hinge will have the very specific hole locations that can be reviewed and ought to be reviewed at the link below this video to the document called template. Okay, that template will allow you to review the specific locations of these screw holes. Those specific locations are unique to the 4321 along with the 1/4 inch radius corners. But those two facts conspire to mean that this hinge is intended to be used on Permadoor manufactured doors and frames, is where you'll see that this specific hinge layout. Okay, so that's important to know. The 400 in the part number, that means that this hinge is 4 inch tall, and it means that it's 4 inch wide. Okay, the 633 in the part number, that means, that means two things. First of all, that means that the hinge is made of steel, and that the finish on the steel hinge is satin brass. Okay. Now, this is, in essence, a single acting spring hinge for Permadoor manufactured doors and frames, 4x4 in a satin brass finish. Very common. Speaking of all those holes, screws are included. You'll get all machine and all wood thread screws in a complementary finish. Now, it's a single acting spring hinge. You're going to use this on doors that require a self-closing feature to them, whether they are fire rated, which would require a self-closing aspect, or if they might be the common entry to a 3-flat residential building, and that door needs to be self-closing because there's an electric strike connected to the intercom system, something like that. Okay, you would be buying this because you're either replacing an existing hinge or hinges, or you're doing a new installation and you want them to match the existing that you already have, or you're doing 1/4 inch radius corners, which are very common, versus square corner or 5/8 radius. 1/4 inch radius is common because when the door manufacturer is routing the prep in the door and frame, and they've got a 1/2 inch 2-flute carbide bit in the router, that's going to leave a 1/4 inch radius, saving them the work of having to go back and square the corners out, which is why you're going to see 1/4 inch radius. You don't really see it other than having the intention to save the work of squaring out the corners. Routers do round finishes well, just not square finishes, square corners. That link to the template, before we move on, also calls out that the leaf thickness of this hinge is 96 thousandths. And that's very typical and common for a 4x4 spring hinge like this, still residential sort of caliber in its leaf thickness. Now, moving down through the rest of the extended description, it's full mortise. You can see from the swag on the hinge leaf here that when the leaves are brought parallel, they're meant to be mortised flush to the edge of the door and frame. This is UL listed for fire-rated applications, where you're going to see that attached garage to a home. That door is probably 20-minute fire-rated and needs to be self-closing and self-latching to be a fire door. These are non-handed. You can use this hinge either way that you like. Not a problem at all. Okay, self-lubricating bearings, that's the LB part of the part number. Easily adjustable spring tension, which we'll get to in a moment. Special template hole pattern, and that's the Permadoor reference below it. That's what these are designed for. The pivot point aligns with residential butt hinges between 85 and 109 thousandths thick. What that means is this. You've got a 6'8" door, you're going to have 3 hinges on the door, and really only 2 of them are going to be spring hinges. Okay. You can mix and match this with other 4x4 hinges that are within the 85 to 109 thousandths leaf thickness. And that axis, the vertical axis of pivoting, will be compatible with mixing and matching. Okay, that's the point we're trying to make with that. Made of steel, 1/4 inch radius, 8 holes. Screws are included. Number 10 by 3/4 or 1024 by half machine thread screws. Now, two things remaining in this video: where you use it, the specifications by which you'll use it, and then how to set the tension. Let's go over the where you'll use it guidelines first. This hinge is intended to be used on doors not larger than 3 foot by 7 foot. If you have a door that's 85 pounds or less, 2 spring hinges and then 1 ball bearing standard hinge would be a good way to approach that. Putting that ball bearing hinge, get a ball bearing hinge for this, up at the top, because that top hinge really does, or gets the brunt of all the abuse of the weight of the door constantly hanging and pulling it down, in effect severely stressing the internal components of a spring hinge, that because the hinge is being asked to do 2 different things, hold the door and close the door, it's really only made with the closing of the door intended in its original design. So middle and bottom hinge would be where you'd go with 2, and obviously if it's 3 hinges, if you had a door that was up to 110 pounds, you're going to do all 3 spring hinges in all 3 locations. Those are the guidelines. Now, I'm a fan of all spring hinges all the time. Here's why. I find that you have better control over a door when you are allowing more springs to do the work of, or to do the same amount of work. I'm not a fan of all spring hinges for the obvious reason. I'm a fan of them because experience tells me that you'll get more predictable and more reliable sort of door operation out of a door where you have reserve spring power on tap, so to speak. A residential application's 3 flat front common entrance. You know, the wind, air pressure conditions, the conditions that the door has to operate in will change over the lifespan of its lifespan, and also, of course, the annual cycle of weather. In the summertime, you're going to need less tension typically on that because you've got a different sort of static amount of pressure that's going to be operating on either side of the door. Windows will be open, air will rush through when that door is opened up, and possibly slam the door. Sometimes in the winter you'll find the opposite condition where you like to kick the spring up a little bit. Also, depending on your door conditions, you might have a frame that's really not plumb, and that door is technically very exaggeratedly moving up like this, because you might have the one jamb that's been kicked out, and the door really is fighting gravity a little bit because of how that frame is set. I find that you're able to get better, predictable, reliable operation out of the door with reserve spring power. That door's got to overcome, the spring hinge actually has to overcome the weight of the door, the fact that it's at a standstill. All that stored energy needs to be released like this, and it's not a real efficient way, I suppose, to do that. It has to overcome the surface area of the door, all the air pressure it will encounter, friction of the latch bolt hitting the strike plate, it has to overcome that. Any weather stripping that's been installed, any poorly fit frame where it's, not plumb, towed in or out, and has to be self-latching, and that's one of the 2 requirements of a fire-rated door: self-closing, and it has to latch. And if you're not doing one or the other, you don't have a fire-rated door technically. I liken it to a tugboat in most spring hinges. They don't pull a lot of weight. Pardon me, they don't go very fast, but they can pull a lot of weight. So there's additional torque inferred in additional spring hinges. They're inexpensive. You can add one later should you find that your operation is not up to snuff. But the majority of installations are 2 spring hinges and a standard hinge. It should be a ball bearing hinge. Now, how to set the tension. Okay, great. So when you get the hinge, you're going to attach it to the door and frame. Your door is going to be hung. It's a done deal. If you're replacing existing, you'll change them one at a time. In this example with the tension collar, you'll see that there's nothing down here, but there is here. That's called the tension collar. With the tension collar pointed towards the top, in this example, you will insert the tension rod, and for every order you'll get at least one. You'll get 1 tension rod for sure. You'll insert that, and I'll just poke it out of the packaging here, into the tension collar. And because the collar is pointed towards the top of the door, you turn it clockwise. It's on the bottom, you'll turn it counterclockwise. As you do that, you're going to reveal new additional holes. And it's into one of those new additional holes that you will insert the included tension pin, and for every hinge, you'll get one tension pin in the order. Okay. Speaking about the guidelines, you will have a link. There is a link below this video called Certification and Hinge Selection Guide. It's an encapsulation of what we've discussed in terms of quantity. So it's there. If your order comes in a box, which it may not, but if it doesn't, the link is there. If it does, it's on the back of the box as well. Now there's a reference there to how many holes are maximum to be set based on the quantity or the degree of opening. And I am failing to quickly see that. I think what you are going to want to do is exceed safely. I'm tempted to say 3 holes of tension. Yes, 3 holes of tension. Okay, that is actually on the link below this video to the installation instructions, which we should have dovetailed into immediately. If your door goes past 90 degrees, pushing out to 180, past 90 degrees, 3 holes, because the more the door opens, the more stored energy. The tighter that spring will get sprung, the tighter that spring will be wound. So 3 holes. If your door is only going to 90, 4 holes is okay. And that's how, by which you will determine if your operation is proper. And that's your installation. That's really all there is to it. There's not really much to say past that. Now, I'm not a fan of spring hinges to close a door. I don't believe that it is not the most efficient way to do it. Hydraulic control would be certainly superior, where you can, and the key word is control. You don't have much control over a spring hinge. It's set it and just let it go. With a hydraulic closer, you are going to have control, where you can control the different sweep areas of the closer itself. But the bottom line is, it's impractical to install a hydraulic overhead surface, overhead concealed floor closer into many applications, and spring hinges are the only way to go. The last thing I'd like to point out to you is the Bommer logo. Right above it, it says Made in USA. That's a fact that Bommer is quite proud of, as am I to represent them. If you have any questions on the Bommer, number LB4321-400-633, and it's of course available in all the common finishes: your brass, your bronze, your chromes, oil rubbed bronze, nickel finishes, prime coat, bright black japanned. Bommer is always willing, almost encouraging, to do special custom finishes as well. Any questions on this or any other Bommer product, please feel free to reach out to us. Thank you.